Today we're going to be talking about Chapter 8, Body Composition, Energy Expenditure, and Energy Balance. So first, we're going to talk about the highly debated topic of BMI. So what should I weigh? So you've all learned in your previous nutrition classes that BMI is your weight in kilograms divided by height in meters squared, and that below 18.5 is considered underweight, overweight 25 to 29.9, and then we have obese class 1, 2, and 3, which are considered obese. And obese class 3, if you're higher than that, then often that is grounds for compensation or insurance for paying for a gastric bypass or other type of weight management surgery. However, when we look at how BMI tends to be used versus how it's supposed to be used, we can see that with a BMI of overweight plus a waist circumference of over 35 in women and over 40 in men, plus any of these health-related risk factors, that's really how BMI is supposed to be used for telling someone whether or not they should lose weight. However, as a lot of people, have experienced in a doctor's office, we see that the typically BMI is used as the sole measure, of overall health, and an overweight label then results in some recommendations for weight loss. This doesn't take into account body type. This doesn't take into account the lean body mass. There's a lot of other factors that we need to look at. So, just remember, if you all become registered dietitians and are working in a hospital setting, that this is the way that BMI was designed to determine what healthy weight is. Ideal body weight in men is 50 kilograms plus 2.3 kilograms per inch over 5 feet. And same thing with ideal body weight in women, 45 kilograms plus 2.3 kilograms per inch over 5 feet. So for every 5 feet, you add somewhere around five plus or minus pounds, as we're looking at, increased body weight from 5 feet. But then you have to also look at body frame, right? And so when you're looking at frame index value, you can see the elbow breadth to height times 100. So this is going to estimate the shift that different people will see if they have different thickness of bones or are large boned or small boned. Percent ideal body weight is actual weight divided by ideal weight times 100. And then you can also see this other factor for ideal body weight, negative 133.99 plus 3.86 times height plus 9.52 times frame plus 3.08 times sex. So when you're looking at these different frame sizes, you can see that, you have a small frame, medium frame, or large frame, which is going to determine, your ideal body weight is going to be a little bit different depending on what your frame size is as well. When we look at the composition of the human body, we have a reference man that is about 15% fat total, 3% essential, 12% storage, 44.8% muscle, 14.9% bone, and 25.3% other components. And for a reference woman, we see that she is going to be about 12% essential and 15% storage fat for a total of 27% body fat, 36% muscle, 12% bone, and 25% other components. And as you've learned in your previous nutrition classes, the essential fat is much different for a female versus a male because our hormonal profiles are a little bit different. Now, when we look at the methods for assessing body composition, there are a number of different types of assessment that we can use. So we can use anthropometry, which are going to be skin fold measurements. We can use densitometry, which could be underwater weighing, air displacement or the BOD-POD to determine body volume, DEXA or single photon absorptiometry to determine through x-rays how dense your bones and muscle mass and water mass are, or CAT or computerized axial tomography, which is going to create visual images of cross sections of the body, or MRI imaging, can be used as well. So just some photos of each of these. So we have BIA, or bioelectrical impedance, measuring the amount of electricity your body conducts, skin fold caliper measurements. We have a little underwater weighing machine. We have a DEXA, and we have the BOD pod measuring air displacement there. We also, as I mentioned, when we look at BMI, if somebody's overweight, we want to measure waist circumference as well, because visceral fat is really an indicator of overall health versus, just our body weight. So when we're looking at visceral fat, it's going to be the fat beneath the abdominal muscular layer. Subcutaneous fat is going to be over the muscular layer, and that visceral fat is really what's going to interfere with the organs and really lead to metabolic diseases. Now, when we look at energy balance minus energy intake is our energy output. And so when we look at our energy intake versus energy output, as we learned in chapter 7, the demands of physical activity are much like the fed and fasted state. So the more energy we're outputting and the more exercise we're doing, the more energy we need. And when we're in imbalance in either of those and not consistently going through our fed and fasted state, kind of filling up our glycogen stores, depositing fat, and then breaking that down in the, proper balance, then we're going to see either weight gain or weight loss. Now, when we look at the prevalence of obesity in the US, we can see that, over 2/3 of the population are considered overweight or obese, and then over 33% of children are considered overweight or obese. So this is a major issue here. So when we're looking at positive energy balance, our energy provided by alcohol, carbs, and fat in that order are going to create, a positive energy balance and contribute to obesity. Carbs are used for fatty acid synthesis when total energy needs are exceeded, as we learned in chapter 7, and fatty acids that aren't used for energy are going to be stored as well. Continued imbalance are going to lead to enlarged adipocytes, which then can divide. So more adipocytes are going to be produced once the fat is deposited in too large of amounts for those cells to be able to hold. So as we can see here, you can see that if energy intake is going to exceed energy expenditure, then the stored fat gets stored in these adipose tissues, which will fill up as much as possible, and then more need to be created in order to accommodate the rest. And this is just showing, increased amounts of any type of precursor, whether it's glucose or amino acids or fatty acids, can all contribute to lipogenesis. Now, when we look at the components of energy expenditure, we can see that they're going to include a few different things. We have basal metabolic rate and resting energy expenditure, which is, the energy it takes to just remain alive, to breathe, for our heart to beat, for our kidneys to function, for our blood to circulate, for us to breathe. It's typically measured in a person in a post-absorptive state, supine, motionless, in a thermoneutral environment. I used to actually measure resting metabolic rate as one of my jobs in graduate school, and it was really hard to get people to be in this post-absorptive state, lying down and actually stay awake for a half hour in order to measure the energy expenditure. We also have the thermic effect of food. So a higher protein diet is an increased thermic effect of food, whereas carbohydrate and fat has lower effect, so it takes less energy in order to digest those two. And then we also have the energy expenditure of physical activity and thermoregulation. So that will be alterations in metabolism that occurs as the body maintains its internal temperature. So the major one that we can change is the physical activity, right? So we can increase our physical activity in order to increase our energy needs. And we can assess energy expenditure using two different methods: direct calorimetry, which is going to measure the dissipation of heat from the body, or indirect calorimetry, which measures the consumption of oxygen and expiration of carbon dioxide. This will give the respiratory quotient and substrate oxidation, and the respiratory quotient as well as energy expenditure. So this looks at, are we the substrate oxidation, are we burning fat or carbohydrate, and how much energy are we burning total throughout the day? So what does our basal metabolism look like? We can also assess energy expenditure looking at, VO2 max or respiratory quotient while exercising. So that is another method that we might use in order to assess fitness level as well. We can also use doubly labeled water. So there are stable isotopes of water given to a person as H218O and 2H2O, and then the disappearance of those are measured in the blood and the urine for 3 weeks, which then can, assess how much oxygen is going to be utilized. So how much water of the doubly labeled water is going to be utilized over a 3-week time period, which then can measure, how quickly and how much the TCA cycle and electron transport chain are utilized. And then we can assess energy expenditure through a variety of mechanisms as well. So we can use the Harris-Benedict equation as well as the Mifflin-St. Jeor equation. And so these are two slightly different equations. Typically in nutrition, we often use that Harris-Benedict equation, but take a look at both and see, which is greater, which is less, and which is a little bit more like maybe some of the apps and things like that you're seeing online. Typically apps like MyFitnessPal or FitDay or those sorts of things use these equations in some sort of way, or if it fits your macros, in order to recommend macronutrient intake. And when we look at the activity level here, which is typically measured, a lot of people will misestimate their physical activity value. So as you can see here, you can estimate your physical activity value based on your daily total physical activity, and that might be physical activity of work, or that could be physical activity for leisure activities as well. And when we look at the Food and Nutrition Board's recommendation, we can see that EER, or estimated energy requirement, can be 662 minus 9.53 times the age plus the physical activity level times 15.91 times weight plus 539.6 times height. So you can see that the EER is going to take into account your age, your physical activity level, weight, and height, as well as your sex. And so all of those things are going to be factors that come into play there. And then there are a variety of things that are going to regulate our body weight and composition, including genetics as well as hormonal influences, which after reading Chapter 8, you should have a good understanding of. One way that we can look at, regulators are our set point. This is a theory that states that our body likes to fluctuate plus or minus 10 pounds. And when our adipocytes are at their set point size, then, we're at a healthy body weight for us. And then we also can see that with some of these hormonal influences, leptin is a big one. Leptin is a hormone that is going to respond to the size of adipocytes. And when they're too big, they're going to cause us to eat less. When they're too small, they're going to cause us to eat more. And when we see, certain animals, for example, this is the OB mouse that tends to keep eating, he does not have adequate leptin receptors. And so there's no hormonal response for overconsumption and the increase in adipocyte size. And so that mouse is going to keep on consuming even though the adipocytes are large, and thus he or she keeps gaining weight. So when we look at some of these different regulatory mechanisms, we can't blame the obesity epidemic on leptin, of course, but we can see that there are probably some genetic influences and hormonal influences that are going to change, different people's hunger and fullness signals, determine people's set point size, et cetera, et cetera.